Hi everyone, I'm Chandler from Stanford. This video is a presentation for our EMRP findings paper, Getting More Out of Mixture of Language Model Reasoning Experts. This is joint work with Weijia, Chen, Luke, and Jordan. The motivation of this project is that we observe some limitations of current large language models like GPT-4. We know that specialized prompting methods like chain of thought can improve their accuracy on specific reasoning types, but they lose generalizability across different reasoning types. For example, if you do retrieval augmentation on GPT-4, it can improve factual reasoning, but will also reduce accuracy on math and common sense reasoning, as we will show later in the experiments. Second, black box large language models lack interpretability. As a result, they cannot reliably decide when to abstain from answering, and users cannot easily tell whether the generated answer is correct. To resolve all these issues, we propose a new framework called MAU, Mixture of Reasoning Experts. The first step is to obtain a diverse set of specialized models for specialized prompting. In this case, we include retrieval augmented prompting for factual reasoning, future chain of thought for multi-hop reasoning and math reasoning, and also general knowledge prompting for common sense reasoning. The second step, given a query, collect predictions from all specialized experts. The third step is to train a classifier to score each candidate answer and select the best one. The fourth step, if the score of the selected answer is below the threshold, the system will abstain from answering. Importantly, users can decide whether to trust the final answer based on the internal answer selection process. Let's look at the experiment results. The first block of the results shows a single expert baselines, and you can see that if you only use one specialized prompting method, for example, if you use the factual expert, it gets high performance on factual reasoning datasets like NQ, TrivIaQ, and Squad, but it will lose transferability on other datasets like math and common sense. And as a result, if you look at the last column on micro average accuracy, they don't perform that well. In contrast, for our proposed method where we ensemble multiple experts with a mixture of reasoning experts, if you look at the last row of using random forest router to select the best answer, we get an average accuracy of 57.6. It's better than all the baselines in the first block. We also evaluate automatic abstention. We can see that our proposed MAU system is better than all the other baselines. For example, when maintaining an accuracy of 80%, the MAU calibrator can maintain a coverage of 55.9, while the other baselines gets much lower coverage than that at the same accuracy level. We also conduct a human trust calibration study where we show questions and answers from baseline and MAU system, and we ask humans, do they trust the answer? And you can see that with a MAU system where we show all the internal decision process and the confidence of the final answer, humans are able to get 67.5 decision accuracy as compared to a baseline with no such internal decision process. And you can see that with a MAU system with a more interpretable internal structure shown to the users, people tend to accept correct answers more often and reject wrong answers more often. And interestingly, it also takes less time than the baseline. We also present a couple case study examples. In the first question from Hopper QA, the question is what documentary was first, Almost Sunrise or Hill Hill Rock and Roll. You get 4 different expert predictions. 3 of them are Almost Sunrise with pretty low confidence. The last one is Hill Hill Rock and Roll from the multi-hop expert. The final selected prediction is Almost Sunrise, and actually the gold answer is Hill Hill Rock and Roll. In this case, the MAU system decided to abstain from answering because the predictions have pretty low confidence. Humans, they trusted the wrong prediction, and their justification is that don't expect Harmony Hub to get simple answers right or others to answer the same. So in this case, they're kind of misled by the fact that 3 of the experts actually answer the same thing, even though they're actually wrong. The second example is, the question is, where is the main place where food absorption occurs? In this case, you can see that the majority prediction is small intestines, and they got pretty high confidence. So it's an easy choice for the system. The system picked the small intestines as a final selected answer, and it's indeed correct. In this case, MAU decided to give the answer small intestines, and humans also trusted the correct prediction. To conclude, in this work we propose a new MAU system, mixture of reasoning experts that can improve both the generalizability and interpretability of current large language models like GPT-4. Check out the MAU experiment details in our paper. Thank you.